Our study takes us into the crurus, ankle, foot, and toes, and it's just way good to realize that the tibia and fibula are the attachment sites for muscles that have their distal attachment that affect knee movement. In this particular model, these blue markings indicate muscles that have come from superiorly insert inferiorly and therefore affect either rotation or flexion extension at the knee. And then you know that the proximal attachments of the muscles that cross the ankle and move into the foot and toes take their rise or their superior attachment from the tibia or fibula. And then down into the foot, anything that's blue represents the distal attachment of the extrinsic muscles that take rise in the crurus across the ankle joint. And then the intrinsic muscles of the foot have their origin and insertion obviously inside the foot. So let's differentiate between extrinsic muscles of the crurus, extrinsic muscles of the foot and ankle that take rise outside of the foot and ankle, and the intrinsics that have both origin and insertion in the foot. It's way important to realize that the two unions between the tibia and the fibula are syndesmotic joints, no degrees of freedom physiologically. Some people think of the fibula as strictly serving the capacity as an anchoring point for muscles. But we realize that in particular the distal articulation, the tibiofibular joint, is the location of the formation of the ankle mortise into which the talus articulates. Way important for stability of the ankle that the talus, go ahead and do this, the talus fits into that ankle mortise and 1 degree of freedom results. Let's look at the contour or the relative lengths of the malleoli. This term is spelled like malleolus, but a little bit more sophisticated to say malleolus. So the medial malleolus is considerably shorter than the lateral malleolus. I'm pretty sure you've been exposed to this. This is the anatomical reason that there are more lateral ankle sprains, because the medial malleolus does not block the movement of the talus like the inversion, like the longer fibular malleolus or lateral malleolus would block that same bone. So fewer injuries to the medial ligamentous structures than the lateral. However, the severity can, in both circumstances, can be very great. Not primarily a class on ankle sprains, but knowing the anatomy helps you understand. It's at this point that I'll put aside the skeletal structure and say we're headed into a study of crurus, ankle, and foot. Let's just double check. The crurus is everything from the knee to the ankle. In the past you've called it the shin, the foreleg. We can call it the crurus. I'll come back again and say the ankle joint is properly called the talocrural joint. It's the talus fitting into the ankle mortise formed by the syndesmotic joint of the tibia and the fibula. Well, let's take a little closer look at this. This is a posterior view of a blown the disarticulation of the bone, so you can really get an appreciation for the relationship of fibula to tibia and the talus. The talus and the calcaneus form the rear foot. So let's come back. So the talus fitting in the ankle mortise, the talocrural joint, and then the joint between the talus and the calcaneus is the subtalar joint. Movements of the foot and the ankle in the sagittal plane, dorsiflexion and plantar flexion. Movements of the subtalar joint in the frontal plane are inversion and eversion, and then movement in the transverse plane are adduction and abduction. So you think of this as, obviously this results from some movement from the knee down, but it's possible to stabilize that crurus and get some rotation into abduction to neutral to abduction. So adduction, abduction in the transverse plane. So if you drop a longitudinal axis right through the middle of rotation of this, that is a triplanar movement. And then it's way important for us to actually know the bones of the foot and ankle. And so what's represented for you here, this dashed line represents the rear foot. You appreciate the fact that the rear foot consists of the calcaneus and the talus, and so and then the other bones of the foot. Please feel free to know this. The calcaneus communicates or articulates laterally with the cuboid. The talus articulates with the navicular. Now it's through this line that's called the transtarsal joint. The functioning at the transtarsal joint is depending upon or determines, I'll back up and say, the subtalar joint determines whether this portion of the foot gets locked or is freed up. I'll talk to you about that in a minute. So back to the configuration. Laterally, cuboid articulates with metatarsals 4 and 5. Talus articulates with the navicular, which articulates with all 3 of the cuneiform bones. We could call this medial, middle, and lateral, or we could say 1, 2, and 3. You'll notice a feature is that each cuboid 1 through 3 articulates with its own metatarsal. And then you know that the MTP, metatarsal phalangeal joints, are where the toes join the foot, and as in the architecture, skeletal architecture of the thumb, the great toe called the pollicis has just 2 phalanges. So there's 1 interphalangeal joint, whereas there's 3 phalanges for toes 2 through 5. And just a note on why we need arches. You can consume this on the PowerPoint that's posted and have an opinion about the longitudinal arches and the transverse arches. We need both of those for the foot to function typically. The way to learn the extrinsic muscles of the foot and ankle is by compartment. And I've inverted this foot. This person's not actually walking on the ceiling, but for you to understand this transsection, this transverse section of the crural compartments, this is what we're looking at. This is a right foot inverted. The cut was made here, and we're looking down on the distal segment. And so appreciate the fact that this is the tibia, this is the fibula, and there is a dense fibrous band that connects the two. And this forms the anterior compartment. I'll come back to that neighborhood and talk to you about that. And then the lateral compartment is comprised of the peroneals, and then there are two deep posterior compartments. There's two posterior compartments. One of them is deep and the other is superficial. So the way to learn what resides underneath the skin is to know the muscles by each compartment. And it's worthwhile for you just to commit this to memory and be able to draw it. Here's another depiction. I'm not asking you to pay attention to all the fine print. I just want to go back through it. So tibia, fibula, anterior compartment has tibialis anterior, extensor digitorum longus, extensor hallucis longus. The lateral compartment, there's a fourth component here called the peroneus tertius. The lateral compartment is comprised of the peroneus longus and brevis. The deep posterior compartment is the tibialis posterior, the flexor digitorum longus, the flexor hallucis longus. That's the deep posterior compartment. The superficial posterior compartment consists of the soleus and the two heads of the gastrocnemius. So this is another way to learn the muscles. And what we'll do is look at the muscle groups by region here on the next video. So at this point, I'm going to sign off and say be students of the Cruris foot and ankle and toes, and check in with you on the next video. Bless you. Bye.